problem solving and data analysis, which is measures of centers. This is a very, very, very easy chapter. I think it's very, very easy. Problem solving and data analysis. We are going to do some data analysis things. Measures of center. We have mean, median, mode are the three major concepts to know, and we have mean quantity, which is basically a parameter, which is the sum of items divided by the number of items. It is called the mean. So we have an example here. What is the mean of the numbers? This, and this. You just need to get the summation of all of these items and the total number of items, the sum of items and the number of items. This is how the mean is found out. Okay, so example number 2, we have some sets of numbers. For an example, 4, 10, 12, and x, and we are just asked to find out the value of x. So we are just going to take the mean of these 4 numbers, which is basically this, and this, and then you just need to divide with the number of items, which is basically 4. And this is going to be the answer for x. Then we have median. We have median because uh, in this chapter, we're going to deal with measures of center. We're going to deal with measures of center. And two measures of center and two measures of center, we're just working with mean, median, mode, just like quantities like this, quantities like this. So median, median is basically a term which is a middle term. The middle term, which is found out when we are arranging from least to greatest. Okay, this is basically how we are finding the median. I'm repeating again. Median is such a number. Median is such a number or numbers, and it is the middle term of a set of numbers. The middle term of a set of numbers when arranged from least to greatest. Least to greatest. For an example, this example number 1, if you're just gonna find out the median of this set of numbers, you need to arrange it. You need to arrange it in least to greatest. You need to arrange it sequential manner, chronological order. Okay, you need to arrange it. You need to arrange it in a well manner. For an example, from least to greatest, and then you just need to find the middle number, the middle term. The middle term. For an example, what is the meaning of middle term? Because we have 1, 2, 3, 4, 5, 6, 7. We have seven terms. We have 7 numbers. We have 7 items. We have 7 numbers. So for an example, so if we are gonna take this particular number, which is the fourth number, then this fourth number on the left side, we are going to have 3 numbers, and on the right side, we are also going to have 3 numbers. So this is basically the set. The fourth item is going to be in a middle position, in a middle term. Okay, in a middle term. So going to the left of these term, we are gonna have the same number of terms, which is 3, and to the right side, we're also gonna have the same number of items, which is also 3. So this is how medians are found. This is how median is found out. So example number 2 also tells the same. What is the median of this set of numbers? You just need to arrange them with the numerical values from least to greatest, and then you just need to find out the middle term. We have 1, 2, 3, 4, 5, 6, 6 numbers, and the median would be the basically the summation of 2 numbers, basically the average of 2 numbers or the median of 2 numbers. So you need to take the median. Okay, you need to take the mean of these 2 numbers to find out the median. So this is going to be just like this, and you are just going to arrange them in a sequential order. Then after that, 6 and 10 both are 6 and 10. 6 and 10 both are in a middle position, because on the left side we have 2 items, and on the right side we have also 2 items. So you are just gonna add them, and you are gonna divide them. So 8 is the median. 8 is the median. Do you get it?
Yeah.
Okay. So we have mode. Okay. We have mode. The most frequent number in a set. The exact same thing. The most frequent number in a set. Note that if a set of numbers has each number appear just once, there will be 0 modes. If a set of numbers has 2 more numbers tiered for appearing the most time, it will have multiple modes. Okay. So in this example, we just need to find such a number which is just going to appear more than once. the most frequent number. The most frequent number. I can see that 9 is appearing again and again. 9 is appearing again and again. So 9 is the mode here. 9 is the mode here. It's very simple. And they're also telling you that set of number can also have zero modes. Maybe there is no mode. It's normal. Zero modes is normal. Having zero modes is normal. Zero modes is normal. So please don't be confused that we have a zero mode. So is that normal? Yeah, zero modes is also normal, and having multiple modes, that is also normal. Having multiple modes, that is also normal. So outliers. What is outliers? Outlier is a number in a set that is quite different from the other values in the set, just like some exceptional, some extraordinary. For example, the outlier is just like such a number which is kind of some extraordinary looking number. For an example, just look at this number. Use your sixth sense. 2, 3, 5, 6, 8, 240. This 240 is quite extraordinary at this moment. Okay, it is quite it is just like some exceptional thing here, because we have a set of numbers and 240 is not like the others, and that's why we're calling this outlier 240. We're calling that outlier is 240 because it is far larger than the others would be considered in an outlier. Maybe for an example, just for an example, maybe -2, -3, -9.99, and -4, 5, and then -22, 20.2, and we have a number +5. So in this set, just giving you an example, +5 would be the outlier. +5 would be the outlier. Do you understand why? Because this 5 is just quite different from these all of this number, because I'm just giving you an example written from my side. Okay.
Yeah.
I'm just creating, because this +5 is a very, very, very different number other than the negative one. So that's why I'm calling this 5 as
Okay.
an outlier. You can do some practice problems here. Definitely you should do some practice problems. It is very, very, very simple. And then we're just gonna talk about the range and standard deviation. Okay. The range and standard deviation. Okay, so the range and standard deviation is basically, range is something which is the difference between the smallest and greatest values in a set of data. Okay, range is the difference between the smallest and largest values in a set of data. The smallest and the largest values in a set of data. So just look at this example. What is the range of the set of numbers? We have a set of numbers. We have a set of numbers. And what is the range? The range is the difference between the smallest and the largest values. As simple as that. 15 is the largest number and 1 is the smallest number. And we just need to subtract them, because to find the difference, we need to subtract. And we're subtracting, and after finding the difference, the range is 14. The range is 14. The range is basically nothing but the difference between the smallest and the largest values. Okay, so standard deviation. The standard deviation indicates how significant the spread of the data in a set is. And we find this standard deviation by using this formula. We find this standard deviation by using this formula. So the standard deviation is the standard deviation is such a quantity which basically tells you, which basically indicates, which basically tells, or which basically indicates that how significant the spread of data in a set is. And to find this, we are using this formula. We're using this formula. This is basically a formula. The standard deviation average of the squared distance of the data points from their mean. Okay. So just look at this example. Look at this example. Look at this example. Which of the following set will have a greater standard deviation? This example, which of the following sets will have a greater standard deviation? We have set X and we have set Y. And to get the solution, set Y will have a greater standard deviation because the numbers deviate more greatly from its mean. The value in set X are more closely clustered around one another. But you can use formula, but they're telling you, fortunately, instead of having you calculate the precise value of the standard deviation, the SAT tests your understanding the concept of a standard deviation. If the standard deviation in a set of numbers is small, the little variation in the data. If the standard deviation in a set of numbers is large, there will be a greater variation in the data. There will be a greater variation in the data. So standard deviation is such a quantity which is calculated by taking the square root, square root of the average of the square distance of the data points from their mean. But rather than they're just not just asking you to have the exact same answer, rather than to tell you how to how to how to try to, at least you just need to get some conceptual understanding so that you can just draw an intuition, and then you can just look at the data set and you can just tell which one will have the greater standard deviation, because these set y, the numbers are not closely clustered to each other. Okay, closely clustered to each other, this is a very 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 important term. This closely clustered to one another, closely clustered to one another. But for y, we are not closely clustered to each other. But for x, we are closely clustered to each other. So that's why y is going to have more standard deviation. Do you understand?
Yeah.
Okay. This is the practice problem. These are the practice problems. You just need to go through these practice problems, and these are quite simple. These are quite simple. And if you don't understand the practice problems, then at least just look at the problems and then think and try to get the solution. This is the most simple way, because this is a very, very, very simple chapter, and we really don't have any kind of complicated problems, just like the other chapters in SAT math. So just look at some pretty tough problems that might be complicated for you. So uh, look at problem number 4. Problem number 4. 20 students were asked how many apps they had on their phones. The results are provided in the table above. If two students are added to this set, one of whom has just 3 apps and the other of whom has 26 apps, how would the median number of apps per student be affected? 20 students were asked how many apps they had on their phones. The results are provided in that table above. If two students are added to this set, one of whom has just 3 apps and the other of whom has 26 apps, how would the median number of apps per student be affected? So they're just giving you a table, which is number of apps on a phone, range of values, and how many students of number of apps in range. Okay, so they're just giving you 0 to 5 persons, 0 to 5 students have 2 apps installed on their phone. 6 to 10 students have 5 different applications installed on their phone, and 11 to 15 students have 11 to 15 7 apps on their phone, and then 16 to 20 have 4, and more than 20 has 2. So
Isn't
they're
it
just
the other
giving,
way around?
sorry.
Isn't it the other way around? Like two
Uh,
students have 5, 0 to 5.
I'm sorry, I'm
Because
not getting your question.
on the thing, it's the number of apps on their phone is 0 to 5 and 6 to 10.
So,
You're saying the other.
can you please ask the question again?
Yeah, no. It's because I was looking at the the heading on the graph. It says the number of apps on the phones. That's 0 to 5 and then 6 to 10.
As we're talking about 20 students were asked how many apps they had on their phones. The results are provided in the table above. If 2 students are added to this set, one of whom has just 3 apps and the other of whom has 26 apps, how would the median number of apps per student be affected? Just from your example, just uh, I'm just telling you that is one of whom has 3 apps and other of whom has 26 apps. Okay. Now let's look how they're solved the problem. How the problem is to be solved. Because there are 20 students, the initial median will be the average of the 11th and 10th and 11th terms. The 10th and 11th terms will both fall between the range of 10 and 15 apps based on the table. If a student with 3 apps and a student with 26 apps were added to the set, they would balance each other out and there will be no impact on the median of the set. Therefore, the median of the set would remain the same. Do you have any issues?
No.
Because they're just telling that because there are 20 students, the initial median will be the average of 10th and 11th terms. The 10th and 11th terms will both fall between the range of 11 to 15 apps based on the table. If a student with 3 apps and a student with 16 apps were added to this list, they would balance each other out. There would be no impact on the median of the set. Therefore, the median of the set would remain the same. Yeah, it would remain the same. So the option C is correct. Option C is correct. We can solve some other problems like 5 students purchased a computer that costs $1,000. The students split the cost equally among themselves I'm solving problem 5, in order to share per person to decrease by $75. How many additional students would they need to share the purchase given that they would all share the cost equally? They would all share the cost equally. 5 students purchased a computer that costs $1,000. The students that split the cost equally among themselves in order to share per person to decrease by $75. How many additional students would they need to share the share in their purchase, given that they would all share the cost equally? The first thing that they've purchased, they purchased a computer which is cost $1,000, $1,000, and there are 5 students. 5 students. So $1,000, if you divide them with 5, then you will get $200. $200. So in order to share per person to decrease by $75, in order to for the share per person to decrease by $75, because we want to decrease it from $200 to $125, because we are wanting it to decrease by $75. Because maybe there are some people who are not able to give it $200 and they just want to share only $125, and that's why it is decreasing $75. Okay, how many additional students would they need to share the purchase in the purchase, given that they would all share the cost equally? I think you can just solve this problem by dividing maybe 1,000 divided by $125, because they're decreasing by $75. So now the cost becomes per head is that is $125. And if you divide this $1,000 divided by $125, you get some answer. Maybe that is 1,000 divided by 125. That is 8. That is 8. So maybe now these 5 students are becoming to 80 students whenever they're just sharing $125 each. So maybe they additionally need some 3 persons. I'm not sure. Maybe my answer is correct or maybe my answer is wrong. So um, let's look at it. Maybe they need some extra person, that is 3. Yeah, I think I'm correct. 125 a person, they students. So I'm correct, maybe. Yes, I'm correct. Okay. So I think they have just done a little bit complex way. Okay? They have done a little bit more complex way. Rather than you just need to don't make all of these things. Just simple. Just think simple. Just think simple. Don't need to make some equations, because it will take a lot of time. Okay, it will take a lot of time. Rather than just focus on the problem what they are asked. 5 students. Do you find this problem complex?
Mm.
Hello.
Can you not hear me?
I was having some issues maybe from your end.
No, I said no.
Okay, do you have any issues with this problem?
No.
Okay, I'm just telling that all the computers are just costed $1,000. Okay,
Yeah.
$1,000, and they are not now able to share $200 because they have decided to share it equally. Okay,
Mhm.
but maybe they are not just able to provide $200 each. $200 each. So that's why they have just decided. So that's why they have just decided to. They have just divided. They have just decided to decided to bring the cost, cut the cost to $75 for each person, and to take it $125. And now this $1,000 of computer is now being split into $125 for each person, and to provide $1,000 per head, $125. We need 8 persons. We need 8 persons, but we have 5 friends. So we need some extra 3 friends to make it 8 persons, right?
Mm-hmm.
Very simple. Just think easier. Statistics problem is just all about thinking simple. It's all about thinking simple and thinking the practical situation. It's not that much complex. So we have some other problems. I think this problem 6 is uh, quite easy because maybe they're asking about some outliers. Okay, the greatest outliers. It's done. Okay, it's done. It's done. We have completed problem 4. Problem 5 we have already covered. I think these are some typical problems. Problem 9 is a nice problem. I think that's a nice problem. And I'm suggesting you to do this problem alone, okay? And this is how our chapter is, this is how our chapter looks like. So we have completed the chapter which is called the measures of center. I have discussed basically, I have already discussed I have discussed mean, I have discussed median, I have discussed mode, I have discussed outliers, and then I have told you to do some practice problems. These are very important. Some practice problems, real problems we have in the next, we had a real problem upcoming next. So practice problem, we have some practice problems, and we have then we have some range and standard deviation. The range is basically the difference between the maximum and the minimum, the highest number and the largest number and the smallest number. And then we have found out about the standard deviation, and we really don't need to find the exact standard deviation by using a formula. Rather than, we just need to grow up an intuition so that we can look at the data. We can look at the data. We can just look at the data, and we can just tell which one has the highest standard deviation. That's it. That's it. We are not asked to find the standard deviation because calculating the standard deviation is not as simple. So to find out the standard deviation, we are talking about, we have told that which is closely clustered and this closely clustered. Closely clustered has more, has less standard deviation. Closely clustered has less standard deviation. Closely, the more closely clustered, the more, the less standard deviation, the less standard deviation. Do you understand?
Yeah.
That is it. That is it. The more closely clustered, the less standard deviation. So this set X has less standard deviation. And then we have some practice problems. Please do it. Please do it. Do this practice problems. Practice problem 1, practice problem 2, practice problem 3, and practice problem 4. And then we have some drill problems, right? Practice drilling, because drilling is the real sad problems that will look like. Okay? This will the exact satellite problems. So problem 9 is suggested for you. So please at least try at this home, and then this is it. We have some solutions. We have all the solutions given here. So practice problem number 9 and problem number 8. That is some amazing problem. And this is how our chapter is ending for this measure of centers and statistics. So we're gonna look some other problems in the upcoming videos.